Okay, this video is going to talk about circles, how to figure out their area and circumference, and a very brief welding application for bending metal and how bending metal changes your job requirements. We'll start by reviewing our circle terminology. So a circle also has a perimeter, just like any object, but it gets its own special name that kind of tells us we're going around a circle. So instead of saying perimeter, if we're just talking about a circle by itself, we use the term circumference, which we denote with a capital C. A circle also has a center, and if you go through the center, touching two sides of the circle, you have a diameter. It doesn't matter where you put it. If you're going through the center, whoops, almost not going through the center, and touching two sides, that has to be a diameter. We're going to give that the symbol little d for diameter. And then if you start at the center of a circle and you go all the way to the edge of the circle in any location, we call that a radius, and we give radius the symbol little r. Other things we should know: that if you want to find a radius, you can always take your diameter and divide it by 2. Or if you want to find a diameter, you can always take your radius and multiply by 2. Of course, we have other formulas relating circumference and area, but we'll get into those. And the other thing we have to think about with circle math is the number pi. It looks like this. Pi has a value, but it's a decimal that never ends. So when you do this math, I'm fine with you using 3.14 as a value for pi, or if you like more decimals, you can add a few more. Or if you use your calculator button, it'll give you, as good of an approximation of pi as we can get. So what this means, if you hand something in to me, our answers might be slightly different depending on whether you use 3.14, 3.141 something, or the full calculator button of pi. So you just have to roll with it. As long as it's pretty close, you're probably right. Our two big circular formulas are going to be area, I can't talk today, and circumference. So area, we give it a big A, and we notice that the formula for area is pi r squared. So whenever you do something and you square it, you're going to get square units. So you can have centimeters squared, inches squared, whatever, but it's always going to have that exponent or the word square when you say it out loud. It's important to use a radius in the area formula. So always convert to a radius if you're given a diameter. It's important to do the squaring prior to the multiplying by pi. So if I did kind of a thing and I said my radius was 3, first I would square 3, which looks like this, but is also the same as 3 times 3 equals 9, never equals 6. And then after you get that, then you multiply 9 times 3.14 to get your area. Circumference is a linear measurement, just like perimeter, so it doesn't have square units. And to find the circumference, we have two ways to do it. We can go pi times the diameter, and that will give you the circumference, or you can do 2 pi r. Now, this is the same thing, because 2r we know is a diameter, so it's really just pi times diameter again, but written in a different order. So just remember, if you do use a radius, you have that multiplication by 2 to get the circumference of an entire circle. Okay, let's do some math. Looking at number 1, find the area and circumference of a circle with a radius of 4 3/8 inches. So first things first, let's change 4 3/8 into a decimal inch measurement. So we keep the 4, and we know it's going to be point, and we just do 3 divided by 8, which gives me the decimal 0.375. Okay, area is pi r squared. So we're basically going to do 3.14 multiplied by 4.375 squared, or 3.14 times 4.375 times 4.375. And when you do that math, it should give you about 60.1 inches squared, square units for area. Okay, can I convert this back to fractions of an inch? Never. If your measurements aren't linear, never use fractions. Stick with the decimals. It's kind of a way out. Our circumference, we have a radius, so instead of using pi d, I'm just going to write 2 pi r, because that's a formula that works with the radius. So we have 2 times 3.14 pi times 4.375. I do that math, and I get about 27, or exact 0.475. This is linear, so it's an inch measurement. You can leave it, depending on what I'm asking, you can leave it in decimal inches. If you wanted to make fractions of an inch, sure. Let's say I wanted to make 16ths. I'm going to keep the 27, and I'm going to add in 0.475 times whatever type of fraction I want to make. I want to make 16ths, and that's going to give me 27 and 7.6 over 16 inches. That's horrible. You never mix your fractions and your decimals, so we would say it's 27 and 8/16, and we always reduce to 27 and a half inches. So not an exact answer, but you know, once we use pi, nothing is anymore. Okay, so that's number one. Number two, we'll switch to another color. Area and perimeter of the figure below. Okay, so the area, it's a circle, but it's like a Pac-Man. It's got like the mouth cut out of it, right? So how much of a circle is this? 3/4 of a circle, right? So how much area will I have? I'll have 3/4 of the area, which is the same as saying 0.75, 3 divided by 4 times area. So if you have a part of a figure, sort out how much you have so that the math works out really nicely. Our area is going to be pi r squared. So how do we get there with this figure? Well, first of all, we need to make a radius. We're going to take 4.5 millimeters divided by 2 and get 2.25 millimeters. The other thing we need to do is remember that we only have 3/4 of that circle. So for our particular case, our area is going to be 0.75 times pi times, sorry, I'm running out of room here, 2.25 squared. And we'll see that we get about 11.92 millimeters squared. Answer. For the perimeter of the figure, notice the word, and here's a kind of a giveaway. The word is perimeter because it's not just including a circle. So I'm going to move this up. Maybe I'll erase my 4.75 up here and do my perimeter calculations up at the top. Let's see what goes into this perimeter. We're going to have 3/4 of a circumference plus this piece, and this piece is a radius, and this piece is a radius as well. Okay, fine. 2 radiuses equal a diameter, so we can shortcut it that way. 0.75 times, and let's think of the formula, pi d for circumference plus a diameter. Excellent. Equals 0.75 times 3.14 times 4.5, and then we're going to add whatever we get up from that to 4.5, which is 2 radiuses. We do all that math, and we should end up at about 15.1 millimeters. Okay, here we have what looks like a cross-section of a pipe, and we want to find the shaded area, so kind of like a wall thickness, then all the way around. A few things we can do to find this. We can combine formulas and get fancy, but I'm just going to do it like the way we've talked about, finding the area of a big circle, which will be our outer circle here. And then I'm going to consider subtracting the area of the inner circle, which is just a white area, what I would cut out if it was a piece of paper. What's going to be left if I do the area of the big circle minus the area of the little circle? I'm going to be left with the area that is shaded. So it'll work out perfectly. So let's get some information. So for our area of our big circle, we'll call it area big, we're going to have pi r squared. We have to do a little extra work here because we are given diameters. So we're going to take 2347 millimeters, the diameter of the bigger circle. We're going to divide it by 2 and get 1173.5. So our area is going to be 3.14 times 1173.5 squared. This is going to be a big number. That's fine. To the nearest whole square millimeter, I'm getting 4,324,101 millimeters squared. For our inner circle, the area of the small one, same formula, pi r squared, where this time the radius will be the diameter of the inner circle, 2185 divided by 2, which is about, like how I say about at the wrong time, 1092.5 millimeters. Okay, so our math process is exactly the same. And like I said, there's a lot of fancier ways to do this, but this will get you there. I've got 300. Why is this? Oh, no. Almost had a bigger area there. Math calculation had to be corrected. So 3,679,472 rounded to the nearest square millimeter. And finally, to get the total area that is shaded, I'm going to take my bigger area of the outer circle. Like that 101 because that really matters. Minus my smaller area. And here we go. I'm getting 644,629-ish millimeters squared. Okay, now that's a lot of millimeters squared. If I wanted to convert to centimeters squared, that's always a possibility. And remember, if we were going millimeters to centimeters, we would move the decimal one place over. But because we're going in square units, we have to do the same action twice. So move the decimal one place 2 times because of that square. So the conversion between millimeters squared and centimeters squared. There we go, with a little bit of rounding. We have a similar problem here. We're cutting holes, but this time we're cutting holes in a rectangle. So the idea, let's say this is circle A, circle B. I would think that if I wanted to find an area, I would take the area of the rectangle and I would subtract the area of circle A, and I'd subtract the area of circle B, and that would leave me with the shaded area. Perfect. Let's start with the area of a rectangle. We've got a length and a width given to us, very easy. So we take 95.6 and we multiply it by 54.5. And notice I'm switching between the x's and the brackets for multiplication, but they mean the same thing. Sorry to be annoying. And we have square inches. The area of our bigger circle A is going to be pi multiplied by 21. How come not 42? Because that's a diameter squared, which is going to give me about 1385 inches squared. And my area of the smaller circle will follow the same math. 3.14, divide 39.8, a diameter, by 2 to get a radius of 90.9, which you square, then multiply by that 3.14, giving you about 1243 inches squared. And then finally, we go up and do this math. You can add the circles first, but just make sure you're consistent. So respect your order of operations, respect the ideas of brackets. Don't get creative. And we're going to get 2582 inches squared. Now, if I wanted to make this into feet squared, we have to think about what happened with centimeters to millimeters or millimeters to centimeters. We had to not just divide by 10, but divide by 10 twice. So the conversion from inches to feet is to divide by 12. But here you have to do it twice to make feet squared. So we would do this math, divide by 12, or divided by 12 squared, which is 144, and that should give you about 17.93 square feet. Watch those conversions in nonlinear units. This is a neat question just in terms of trying to set it up. Okay, so we want to build the wooden part, the deck here, around my little hot tub. And I know that my hot tub is 6 feet in diameter, which means I know that my hot tub has a radius of 3. Now I need another measurement for my big circle that's going to go all the way from the center out to this edge. Well, we know we have 3 here, but if the deck is 6 foot wide, 0.5 feet wide all along, all around, this is where the 6.5 occurs. So let's try and get this so it's readable. So I'm going to add a 6.5 to get the total radius. So the radius of the big circle is 9.5. Tricky. All right, if we want the area of the deck, let's get fancy with this. Because we're really doing a pi r squared minus a pi r squared, you can also do a pi multiplied by 9.5, the big radius squared, minus 3 squared. Now you can't do 9.5 minus 3, 6.5, then square it. That math won't work, but you can do this. So we're going to get pi multiplied by 81.25, which gives me about 255 square feet is what I'm going to have for my deck coverage. Fun way to do it, paying attention to what the question is telling us. A neat application for kind of circles is the concept of bending metal or any kind of thing for welding. And the idea is if I take a straight piece of some sort of plate and I bend it, of course on the inside corner it's going to compress. The metal will actually get closer and shorter, and that's a property that it can have. And on the outside of this, even though it's a 90-degree corner, we know that it's always going to have a little bit of a curve. We're going to stretch this out. It'll be longer here. So we have lookup tables and values to figure this all out, but let's imagine that it's the dystopian future and you still have the ability to weld, but you no longer have access to your lookup tables. Is there a quick way you could approximate what original length of metal you would need to make a perfect length of bent metal? Happens, there is. So the math depends on where you're doing your measurements. If you're doing inside measurements, you're going from the top. Let's get some drawing going on here. There we go. You're going from the top to the surface here. You're not going all the way across. That's called an inside measurement. And let's say that measurement is 4 15/16. And our other measurement, inside measurement from here, right, across, is also 4 15/16. And we're using 1/8 inch thick plate. Okay. So here is a math we're going to do. We're going to add those lengths, those arms. We're going to need 4 15/16. And we're going to need another, for sure, 4 15/16. But because it's shortened along the inside, we're going to add some extra to account for the part that got shorter in here. So we're going to add half of the thickness of the metal. So we say 1/8 multiplied by 1/2. That will get us half of 1/8. So we have 4 15/16 plus 4 15/16, and we're going to do this like old school fraction crazy math. 8 30/16, we'll circle back and fix that, plus 1/16. We have 8 31/16. That is an improper fraction in a mixed number. So we're going to pull out, we're going to change that 31/16 into 1 15/16. So go back if you don't remember this. We have 9 15/16. So a little longer than what you might have expected. If we measured the same piece of metal or plate on the outside dimensions, maybe we found that we got 5 inches for C and 5 inches for D. And our thickness is still 1/8 of an inch. So in this case, you take the arm lengths, your 5 inches, much easier math, plus your 5 inches, and instead of adding 1/2 the thickness, because this should be longer than we thought it would be, we are going to subtract 1/2 the thickness. So we have 10 minus 1/16, which should get us to exactly the same location, 9 15/16. So if you want to do this, your flat out length that you start with is going to be 9 15/16 inches. So here we go. Our plate is 1/2, so we know that 1/2 of 1/2 is going to be 1/4. So we're going to be adding or subtracting 1/4. That's going to be our correction. We're making a 90-degree bend, And we have inside measurements. So we're going to take 2 3/4, all the measurements we have, plus 3 3/4. And then because these are inside measurements where the metal is going to be shorter, we're going to do that correction, which is adding a 1/4 inch. Same kind of Franken math. We get 5 for the whole numbers. We get 6, 3 plus 3 plus 1, 6, 7 over 4. That's disgusting. Change it to 5 plus, and I'll do this one a little slower. 7 over 4 is the same as 1 3/4 as a mixed number. So we should have 6 3/4 inches. Here's a much dirtier question. We have our sides labeled 1, 2, 3, 4. We have what looks like outside measurements. So we know that we're going to do outside measurements. Subtract a correction. Okay. We're just unfolding this thing so that we end up with a flat plate that has the chunks that were 1, 2, 3, and 4 that got bent up. And here was our little corner, looked like it happened between 3 and 4. That's where our weld happens. So obviously that's not where you cut it from, but you know, the idea is there. So first let's make sure all our lengths are going to be the same. 1 and 2 are going to be great because they go the whole length. So they are both going to be 18.375 inches long. Now 3 and 4, they end a little short. How short do they end? They go almost 18.375 inches, but they are missing one thickness, and one thickness is 1/8 or 0.125. So those two will only be 18.25 inches long. Okay, so let's just get all the lengths, the big long ones. So our math is going to be 18.375. You can add everything, or you can be lazy and multiply, plus 18.25 times 2, which gives us 73.25 inches. Okay, now we have outside measurements, so we know we have to have a subtraction correction. Minus 1/2, or 0.5, times, so that's our correction, the thickness that we were given, 1/8, 0.125, that's our thickness, times 3. Where does this 3 come from? 1, 2, 3 corners, 3 bends. So don't forget about that part. We'll have the 73.25 inches. We will subtract 0.1875 inches, giving us 73.0625 inches as that flat length. This question's a little more complicated because they're asking for an area of plate. So thinking of that, if we cut it right here and we unfolded this so that our entire distance around is our flat out length, and we can think of that as our length, and then for area we have another dimension, width, so we're going to take whatever we get in yellow and multiply it by the purple to get the total area of plate that was used to make the sides, not including this end plate, and probably the other one on the other side. Okay, we'll figure out our yellow length first. So we see that we have inside measurements, so we're going to start by being lazy. We're going to change 18 5/8 to 18.625, and we're going to multiply that by 4 because we've got a square situation here. I can tell because I've got 2 measurements, and I can assume, well, no, they're given as 90 degrees, so I know that this is a square. I do that math, I'm going to get 74.5 inches. So my correction, I'll take my 74.5, because they're inside measurements, I'm going to add 1/2 the thickness, which is 1/8 inch again, multiplied by 4, because I have 4 corners that have bends this time. I did my weld right here. That'll give me 74.5 inches, plus the correction, which will be 1/4 inch, And that gives me a total length of a flat that I need 74.75 inches. Am I done? No, I've just found the yellow length. Now I need to multiply it by that 63 inches. So my area is length times width, which will be 74.75 multiplied by 63, giving us 4,709.25 inches squared. Another way flat plate can be bent, or let's say rolled, is in a circular way, so that you're going to make like a pipe. And this pipe, when you fold it up, and I know you don't weld it that way, but maybe you have a shop where more than one thing happens, and sometimes you get stuck on the roller, and sometimes you get to weld, who knows. We have an inside diameter here to here, and we have an outside. So this looks a lot like our ring problems or our pipe problems from just our other math. This is a little more complicated though than our 90-degree bends for bending metal, because we're going to need to find the distance around the middle of our circle. So we're needing to find an average circumference. But what we'll be able to find first is a diameter that we have to then incorporate into a circumference calculation to find the flat out length. Okay, and here's how it works. So come with me. If I wanted to make the outside diameter, so from here to here in this circle, I would have to take the inside diameter here to here, and I would have to add one wall thickness, two wall thicknesses. So if I have to do that to get from inside to outside diameter, it works out that if I want to find the average diameter, the dotted line in between the inside and outside, I'm just going to kind of do this correction. That's one wall thickness. So if I'm given an outside diameter and I want an average diameter, I subtract one wall thickness. If I'm given an inside diameter and I want to find the average diameter, I'm going to add one wall thickness. If I don't have the wall thicknesses, you can figure them out from inside and outside, but you can also just do outside diameter plus inside diameter and then take your answer and divide it by 2. Let's see in a problem. We're giving an outside diameter of 18 inches, and we know that we have 3/4 inch plate, which is going to be one wall thickness. It'll be 3/4 inches. Okay, so to get from an outside diameter to an average diameter, 18 minus a one wall thickness equals 17.25 inches. I use this average diameter to find a circumference, which will be our flat out length, our unrolled length. Equals C equals pi times 17.25. This gives me 54.165. Now, and I know, just like a soup can label, this is this distance around. So if I want to like cut this pipe right here and unroll it, it'll become a rectangle. That circumference is along here now. Obviously, this is terribly not to scale. And this 6 feet, okay, mixed measurement, so change it. I'm going to make it into inches by multiplying by 12. It's going to have these dimensions, that rectangle, 54.165. If I multiply 54.165 by 72, I get my area, which is really close to 3,900 square inches. And for our last example, we're going to take a pipe and roll it up from 1/2 inch plate. So I know that my wall thickness is 0.5 or 1/2 inch. I just want the flat out length of plate, and I have an inside diameter that is required to be 1 foot 3 inches. Let's convert that. That's 12 inches plus 3 inches equals 15 inches. Okay, that's an inside diameter. So my average diameter equals 15 inches my inside diameter, plus a single wall thickness equals 15.5 inches. Here they just want the flat out length, so I'm finding the circumference in disguise. I take that average diameter and multiply it by pi, and I'll get my flat out length. Bear with me, I'm actually using my calculator because I didn't write it down. We get about 48.67 square inches. Nope, it's a length. There we go.